Okay, so in previous lecture, we have seen about operation of binary search tree, right? Like finding an element in binary search tree BST, finding minimum element. मतलब हमने previous lecture में देखा था कि operation of binary tree, search tree जैसे कि finding minimum element in BST, then finding element in BST, then minimum element in BST, then finding the maximum element in BST, right? ऐसे कुछ हमने ऑपरेशन देखा था. Then inserting an element from binary search tree BST, that is nothing but binary search tree. Then deleting an element in from the binary search tree. So इस types के कुछ operation we have seen in my previous lecture. So today we're going to see BST, that is a binary search tree. Okay, so today we're going to see this one. Okay, just okay. So binary search tree. So binary search tree is a node-based binary tree data structure. Okay, binary search tree is a node-based binary data structure. The left subtree, okay, of nodes contain only nodes with key lesser than nodes key. The right subtree of node contains only nodes with key greater than nodes key. The left and right subtree each must also be binary search tree. Binary search trees are a nice idea, but they fail to accomplish our goal of doing lookup, insertion, deletion each in time. When there is an end item in 3, imagine starting, suppose, okay, why I said they fail, suppose 1, okay, then mm, okay, 1, then okay, 1, then you can say here you can put 1, then suppose here, wait, we will do suppose 1, okay, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4. Okay, so consider this like this manner. Okay, one in one row in second column, and this third one and this fourth one, like consider like this. Okay, so starting from 1, then it increase 2, then 3, then 4. So here see, binary search tree are a nice idea, but they fail to accomplish our goal of doing lookup, insertion and deletions. So when there is an item in tree, imagine starting with an empty, that is a tree, inserting 1, 2, 3, and 4. Right? You do not get a branching tree, but a linear tree. All of the left subtree are empty. Okay, because of the behavior of worst case of each operation. Look up the insertion and deletion. Take an from the so here. Uh, so, example consider, see here. Here, for example, if the given travels is 10, 5, 7, 7, 40, 50, then the output should be root of the following tree like 10, then after this 5, then 1, 7. You know, we are starting from leftmost, then right, then 40 and 50. Okay, so this is the example of VST. For example, suppose method, take this. The first element of the pre-order travels is a allow always root. Okay, so the first element, just 1 minute, just take this in below. Okay, so the first element, if you the first element in travel, the first element of pre-order travel is always root. ओके, जो फर्स्ट एलिमेंट होता है वो ऑलवेज क्या होता है, रूट होता है. ओके, दिस वन. ओके, सो ओके ओके सॉरी, the first element of pre-order travel is always root. We first construct the root. Okay, so हमने पहले root construct किया, right? Then we find the index of the first element which is construct the root. Then we find the index of the first element which is greater than root. So we will find the construct element which is greater than root. Then we find the, see, right, we find the greater than root, right? Then we find the index of first element which is greater than root, and let the index be I. The value between root and I will be part of the subtree, and value between I plus 1 and n minus 1 will be part of the right subtree. For example, here you can see this example: 10, 5, 7, 7, 40, 50 there, right? 10 is the first element, right? So we make it root, right? Now we look for the first element greater than 10. So we look for the first element which is greater than 10. So we find 40 and 50, right? We know the structure of BST is as follow, right? So BST का structure कैसे follow करता है? First of all, element starting से वो root, मतलब जो भी first element होगा it will be root. The according to BST means binary search tree, always it की means consider करता है first greater than the root. So यहाँ पे हमें root से greater than क्या मिला number, because 5 is not greater than 10, 1 is also not, 7 also not. So 40 and 50 ये greater than है root से. So according ये हमने put किया right most में. So according to binary search tree, whatever we get the highest element we have to put in this side. Okay, so this is about your binary search tree. So here height balance tree. So the highest of the node height balance tree, the highest of the node in tree is the length of the longest part. So जो highest node tree होती है वो किसके ऊपर depend करती है? Longest part. Okay, from the node to leaf node, counting both the start. Okay, then we define the balance factor of the tree. Okay, so let me tell you. See this diagram. Okay, balance means we define the balance, means we have seen the balance tree, right, in my previous lecture only. And height leftmost tree and rightmost tree, मतलब अगर यहाँ पे tree है, okay, suppose it 23 balance factor है, okay, just a minute, 3 balance factor है, तो उसकी leftmost और rightmost we have to put it. Okay, this is about BST. Then now let's see AVL. AVL here. So AVL, that is Adelson, Welsick and Landis trees. AVL tree is also binary search tree, but it is a balanced tree. Okay, it also binary search tree, but it is a balanced tree. So in computer science, AVL tree is a self-balancing binary search tree. It was first search data structure to be invented in an available AVL tree. The height of two child subtree of any node different by most one. If any time any differ by more than one is done, restore the property. So AVL. Okay, so AVL it is also binary search tree, but is a balanced tree. The technique of balancing the height of binary tree was developed by Adelson, Welsky, and Landis, and hence given a short from a AVL tree or balanced binary tree. A binary tree is the said to be balanced if different between well, you can say height to left and right subtree of every node in the tree there minus 1 0 or 1. An AVL tree is defined as follow. AVL tree is a balanced binary search tree. So the AVL tree binary search tree, every node is a satisfy balance factor condition. So there is a set to be AVL tree. AVL tree rotation, AVL tree performing every operation like means AVL tree is performing like insertion, deletion, so means deleting, inserting, or check balance. Okay, so yeah, in balance factor, so if there is a satisfy the balance factor condition, then we conclude operation, otherwise we must make it balance. So whatever मतलब अगर वो balance factor conclude होता है तो ही हम बोल सकते it is a AVL, otherwise we can't. So rotation operation are used to make a tree balance. The four rotation operations classify into two types: single rotation and double rotation. So यहाँ पे कुछ rotation operation है, okay, like a single rotation and double rotation, double rotation. So let's check it, single and double rotation. So in single rotations also having both point, that is L rotation and RR rotation. L rotation and RR rotation. Okay, so let me this first. Okay, so single LL rotation and RR rotation. LL is nothing but left rotation. Okay, and RR is nothing but right rotation. Means left rotation. You can say LR and RR. You can say LR. That is left rotation and RR rotation. So single rotation, single left rotation, single left rotation, left rotation. In single left rotation, let's see what the meaning of in single left. If a tree become unbalanced, okay, right, unbalanced tree. If a tree become, let's take the first diagram, then you will get better. Okay, just 1 minute. Okay, where we are in single rotation. Okay, like this we will draw this diagram, then you will get. Okay, this is the, okay, so here this is A, this first A, B and C. Okay, so in this you can write here A, B, C. Let me draw this first. Okay, so A, B, C. So you can count these like 0, 1 and 2. Okay, 0, 1, 2. So this is the right unbalanced tree. Okay, so here you can say that um, if a tree becomes unbalanced when node is inserted into the right subtree. Okay, node insert into right subtree. So the right child, then we perform a single left rotation. Okay, so in our example, node A has become unbalanced as a node is insert in a right subtree, A's right subtree. We perform the left rotation by making a left subtree. Okay, so this is the LL rotation, that is a right sub unbalanced, and then we have to perform in left side. We have to put in this left side, that is a left rotation, and then if we want to balance, then what we have to do, we have to just put this, see, like this. We have to cut it. Okay, then if you want to make a balance, so if you want left, then you have to put it in this manner. This is right and this is one left, and we know this A is a middle part, so just go and take the balance. We have to do balance here. Okay, so for balance purpose, okay, so this is the balance. Okay, so if a tree become unbalanced when a node is inserted into right subtree, so that वो हमारा unbalanced है because node is right subtree of the right child, then we perform the single left rotation. In our example, node A has they become unbalanced. A node is inserted in the right subtree. Then single right rotation, the RR rotation, then single right rotation here. So left unbalanced tree, right rotation, and balanced tree, like this only. In single rotation only, मतलब ABL tree become unbalanced if node is inserted in the left subtree. मतलब देखो राइट सबट्री में क्या होगा, ABL मतलब जो ये अनबैलेंस होगा राइट साइड में, और लेफ्ट में इट विल बी अनबैलेंस इन लेफ्ट साइड नोड ओनली. So this is all about left subtree and left rotation and right rotation. Okay, so then in double rotation, so let's check the means if the understood the become the right child of child by performing. See, ABL tree may be become unbalanced if, so here we can see that double rotation, left right rotation. The LR rotation is a combination of the single left rotation followed by the single right rotation. In LR means left rotation, first every node moves one position. Every node moved one position to the left, then one position to the right. Okay, one position to the left and one position to the right. Okay, from the current position. To understand LR position, let us consider following insertion problem into AVL tree. So tree first is a imbalance. This is the imbalance because node 3 has balance factor 2. This is the LR left rotation. This is the R rotation, that is which we have seen left side and right side. R rotation, right? Then after LR rotation tree is a balance, मतलब both of इसके बाद tree balance होती जो हम लोग देख रहे थे, right rotation left rotation. Okay, so right left rotation, the LR rotation is a combination of single right rotation is followed by the left rotation. In RR rotation, first every node moves one position to right, then one position to left from the current position. To understand LR rotation, consider this following insertion operation into the AVL 3, right? Okay, so here so we have to see this operation. Okay, so in this we can see the searching, insert and delete. Searching for a specific key in an AVL tree can be done the same way that any balance or unbalance. Okay, searching is same done, and we have to search balance. We have to search first leftmost, rightmost, and we have to balance the both three, right? Then insert. When inserting, okay, when inserting a node in a AVL tree, you are initially follow same process, right? Inserting means you follow the same process. Inserting into the binary search tree, if the tree is empty, then we means suppose we have to first insert. Okay, means inserting. When inserting a node into AVL tree, you initially follow the same process as inserting into binary search tree. If the tree is empty, then the node is inserting as the root of the tree. In case the tree has not only empty, then we go down the root and go down the tree searching for the location of insert the new node. This travel is a guide by the function, it means comparison function. In this case, the node always replace null reference. Then delete. The primary steps to deleting a node are described the searching binary tree. So deleting and this we have the means deleting, inserting, and searching we know very well. We in tree chapter also we study about this deleting and all, right? So this is means ये आपका सेशन में हमने चैप्टर 2 हमारा कंप्लीट हुआ है यहाँ पे. दिस इज BST AVL. So let's see one practical. Okay, let's check the practical. Okay, so let's check. So your practical number 1, that is multiplication, means Python program perform matrix multiplication, right? So we have to do this practical. See, so this is your first program practical, that is the to program in Py. हमें for computer networking में I am दो सब्जेक्ट है, कंप्यूटर नेटवर्किंग एंड दिस वन. सो फंडामेंटल एल्गोरिथम में हमें प्रैक्टिकल सेशन है, और नेटवर्किंग में वी डोंट वांट टू सी दिस प्रैक्टिकल. दिस इज थ्योरी बेस. ओके, सो यहाँ पे फंडामेंटल में वी विल सी द फर्स्ट प्रैक्टिकल. दिस इज that this one program to multiply two matrix using the nested loop. You have already studied about loops, right? In your Java also. Next year, last year you have studied core Java, right? So core Java mein you have seen the nested loop and C plus in. So you familiar with loops, right? So no need to explain in detail about loops, right? So we have to take the three matrix here. So that's why मैंने read मतलब comments में मैंने show किया. And we know about Python also. हमने Python भी देखा, right? So no need to explain how to save Python file, how to download it, right? You are familiar with this all Python, this software and all. So here, take three matrix. Then this is our matrix first. A में एक मैट्रिक्स हमने लिया. देन टेक 3 into 4 मैट्रिक्स. ये हमने A में 3/3 का मैट्रिक्स लिया, इसमें 3/4 का. सी 3 into 3/3 and 3/4 का मैट्रिक्स लिया. ओके, now result this. So inserting by row of A for I in range length A. Inserting by column by B for J in a range length B of 0. Then here rows of B for K in range, then resulting. So this is a formula, and then we have to print result. मतलब whatever हमें answer result में, इसलिए हमने यहाँ पे print दिया. Okay, so this is a case sensitive. No need to again say in deeply. जो भी red line में वो comments through आपको समझाने के लिए I have put it this. Okay, so this is a formula. With the help of this we can get our match output. Okay, so ये loop में follow होगा. Okay, so यहाँ पे print मतलब हमें result print करना है. So let's run it. I already save with Python extension, right? .py. I already saved this file. So let's run this file to check our output. This is your first practical. So we will get an output here. सो ये दोनों मैट्रिक्स का जब हम लोग मल्टीप्लिकेशन वॉट एवर इज गिवन अकॉर्डिंग टू दिस फॉर्मूला, जो भी इस फॉर्मूला के अकॉर्डिंग हम लोग मल्टीप्लिकेशन वी विल गेट दिस आउटपुट्स. ओके, सो दिस इज अबाउट योर फर्स्ट प्रैक्टिकल इन फंडामेंटल एल्गोरिथम. ओके, सो टुडे सेशन में हमने सेकंड चैप्टर कवर किया है एंड फर्स्ट प्रैक्टिकल देखा है. ओके, so okay, so today's lecture over here. Thank you.
Any problem? Yes. Faizan, Prasad, Ratuja, Siddesh. देखिए समझ द लेक्चर बोला. हेलो.
हाँ
हाँ समझ लेना. ओके, यू कैन लीव नाउ.